After the Ordovician mass extinction, after 100 to 200 million years, the excess oxygen in the atmosphere began to form an ozone layer, which provided the Earth's land with the basic conditions for life to develop. At the same time, over this period of more than 100 million years, as oxygen continuously oxidized the petroleum and other organic matter that had been deposited underground, the carbon dioxide in the atmosphere and in the water continuously increased until it once again reached a state of balance suitable for photosynthesis and the development of life. Because the effect of photosynthesis on land was much greater than in the ocean. From the Silurian period onwards, first mosses and then primitive ferns appeared in coastal and near water areas. By the late Devonian, they had evolved from simple primitive ferns into complete fern-like plants. This means these ferns had roots, stems, and leaves, and were physiologically capable of large-scale development on land. At that time, the concentration of carbon dioxide in the atmosphere was about 10 times what it is today. There was a climate created by sufficient greenhouse effect, as well as an increase in rainfall caused by this relatively high temperature greenhouse effect. This allowed plants to march boldly toward all land on Earth. Today, in all places with land from the Carboniferous period, wherever there was land, we can see extremely thick coal deposits. Our most famous Carboniferous coal-forming period began at this time. We often see Carboniferous coal seams that can reach thicknesses of 100 meters or 150 meters. Many people ask, does a 100-meter thick coal seam require thousands of meters of biomass? Is that true? How could there be an accumulation of thousands of meters of woody organisms? Let's return to the natural environment of the Carboniferous period to provide a description. In the early Carboniferous, sunlight was still abundant, and the carbon dioxide concentration was about 5 times what it is today. This meant that the efficiency of photosynthesis, or the efficiency of plant growth, was 3 to 4 times that of today. With sufficient water and sufficient rainfall, plants would continue to grow rapidly. In the process of plants growing, the groundwater would also slowly rise with the plant growth. In some places, the crust was continuously subsiding. Plants continuously developed, grew and died on top of the accumulating layer of coal. How long could this growth continue? A single coal seam might have experienced thousands or tens of thousands of years of continuous growth and accumulation. So during this long development process, the combination of these various environmental factors caused the coal seam to continuously and consistently increase. Therefore, these exceptionally thick coal seams are a result of sufficient time, a sufficient speed of plant growth, and a sufficient amount of carbon dioxide and photosynthesis. It is a fossil fuel formed over a long period through continuous combination. The amount of coal resources stored during the Carboniferous period is so vast. The total amount of coal formed during this period, as shown in a diagram in our book Carbon Cycling. We can see that the area of carbon conversion or absorption formed in the Carboniferous period, that is, the volume of biomass formed, was greater than the total amount from all subsequent coal-forming periods combined. This includes our Shaanxi province. As of today, 40% of Shaanxi has coal. However, when it was originally formed, 100% of it was in the same coal-forming environment. This means that 60% of the coal has been weathered and eroded away. The crust uplifted and it was eroded and it's gone. But it still accounts for more than 50% of all the coking coal in China. This large-scale formation and storage of coal brought about several effects. First, it met our energy needs today. Second, it buried a large amount of carbon dioxide within the Earth's crust. Third, it stored the excess solar energy as a reserve of fossil energy or chemical energy underground. This satisfies our needs today. However, it also brought about another effect. When the Carboniferous period reached its mid to late stages, carbon dioxide, which was 10 times higher than today at the end of the Devonian, had become lower than the carbon dioxide content in our atmosphere today. Therefore, in the late Carboniferous, due to the excess oxygen, a global forest fire event occurred. We can see this in our coal seams. A high proportion of the fusinite massal group is a result of this. All the forests on the planet at this time completely burned. For tens of thousands of years after the burning, the carbon dioxide slightly increased. Not long after, the Permian coal-forming period occurred, and it was buried underground again. Therefore, by the end of the Permian period, oxygen reached its maximum, and carbon dioxide reached its minimum. Our atmospheric carbon dioxide is 400 ppm today, but at this time it had dropped below 200 ppm. This once again caused the Permian Major Ice Age. The Earth became a frozen snowball again. After the Major Ice Age, the Permian mass extinction occurred. During the Permian, there were not only marine organisms, but also a large number of land organisms. Therefore, this Permian Major Ice Age and the subsequent Permian mass extinction it caused led to the extinction of even more life forms. Approximately 80 to 90% of marine and terrestrial organisms were largely extinguished during this Carboniferous Permian glaciation period. Another life cycle came to an end.